course Computer Networks. This is S. Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, I am going to discussing about X.25 and frame relay in computer networks. First, let us see the overview of today's session. We are going to discussing about connection-oriented networks, that is X.25. And next, we will be discussing about frame relay, that is connectionless network. And finally, we are going to discussing about differences between X.25 and frame relay. These three topics we are going to discussing in today's session. First, we will see what is X.25. X.25 is a protocol. This protocol is developed by Telecommunication Standardization Sector, that is ITU. ITU is nothing but International Telecommunication Union. This is developed by X.25, and this X.25 is containing series of documents. These series of documents mainly issued by ITU. These documents going to be issued by ITU. These documents is also known as X.25 recommendations. That is X.25. These X.25 mainly for wide area network communications. Mainly it is the main use of these X.25 is wide area network communications. At the same time, these X.25 is defined into these three general categories. Those are DTE. DTE is nothing but data terminating equipment, and next DCE, that is data communication equipment. It is also called as circuit terminating equipment also. And next PSC. PSC is packet switching exchange. These three categories we are dividing X.25. And next, these X.25 mainly supporting the various conversations by multiplexing the packets and also the helping for the virtual communication of the channels. Multiplexing is nothing but whatever data is going to be there means multiple signals. Whatever multiple signals are there, right? These multiple signals that can be transmitted, those can be transmitted over a single medium. Whatever multiple signals are there, those are going to be transmitted to a single communication medium. That is called as single communication medium. That is called as multiplexing. At the same time, virtual communication channel also we are going to use X.25. These X.25 mainly providing the quality of the service. At the same time, it is also talking about the error-free delivery. Whenever the packet is transferring from sender to receiver, there is no errors also. It is provided by the X.25. These X.25 mainly shoots for the lower the levels of the OSI reference model. Already we discussed OSI is having how many layers? Total it is having 7 layers. Those 7 layers are, first one is the application layer. First layer is application layer, and the second layer is the presentation layer, application layer, presentation layer, and next one is the session layer, and next fourth layer is the transport layer. Next and fifth one is network layer, and sixth one is the data link layer, and the final one is the physical layer. These are the 7 layers having in OSI reference model. So here these layers are called as the higher layers, and these called as the lower layers. So here what I am saying, lower 3 layers means physical layer, data link layer, network layer we are going to using in X.25. It is supporting only physical layer, data link layer and network layer. So first we will discuss what is DTE, what is DCE, what is PSC. First let us see what is DTE. DTE is nothing but data terminal equipment. Data terminal equipment is nothing but it is a end user device. Means here come to this picture, it is DTE, here is DTE, here is DTE, right? DTE is nothing but the sender or receiver, any that may be sender or receiver, we can call it as a DTE. That may be sender or receiver, we can call it as a DTE. That is nothing but end user. Mainly it is for, it may be computer, terminals, all call it as a, whenever the data is going to be initiating and receiving the data, those we can call it as a end users. And these DTE typically located at the customer's premises. Means this is the customer, this is maybe sender, this is maybe receiver. Coming, this is a sender, this is also a receiver. So this is DCE, means it is an end device. And coming to DCE, DCE is nothing but data circuit terminating equipment. Data circuit terminating equipment is also called as data communication equipment also. Data C is nothing but data communication equipment. Means how the data is going to be communicated. Means the device is connected to the DTE to X.25. So this is the X.25, this is the network. This is the network. For connecting DTE to this network, this is the total network. For connecting this particular network, we are going to use DCE, that is communication equipment. At the same time, it is the interface in between the user and network. This is the user and this is the network. For connecting these two, it acts as a interface. It is the interface. That is the main purpose of the DCE. And next here it is going to be involved modems, packet switches, all comes under the DCE. And next one is the PSE. What is PSE? Packet switching exchange. What is packet switching exchange here? So whatever data is going to, core components are there, right? Those core components are comes under the X.25 networks is packet switching exchange. Those are the routers, forwarding the packets. Those are comes under the packets. This main aim is virtual circuits to establish the path for transferring the data between the two DTS. Suppose here is the DTE, here is another DTE. For transferring the data from one DTE to another DTE, here is one DTE and here is another DTE. For transferring the data in between these two DTEs, we are going to use the packet switching exchange. Means suppose if this is the sender, if this is the receiver, for transferring this particular data from this sender to the receiver, it may have number of multiple routes. For selecting the path, we are going to use it. Means whatever it may be, the destination is same. All we have to go to this way only. Means you can choose any route for transferring that particular data. That is called as the packet switching exchange. For that purpose, for establishing the path, we are going to use the PSE. Establishing the path, we are using PSE. That is the main aim of PSE. And next we will discuss about what are the three layers it is supporting. Three layers are the physical layer, frame layer and packet layer. Frame layer is nothing but the data link layer. That is the layer 2 layer. Next one is the packet layer is the network layer. This is the network layer. These three we are using in OSI also. See here it is supporting only three layers, that is physical layer, frame layer and packet layer. So these are the OSI 7 layers. Physical layer is physical layer. It is also called as X.21 in X.25. And next data link layer is called as frame layer, that is supporting LAPB, that is link access. LAPB is nothing but link access protocol or procedure balanced. This is LAPB. That is the frame layer. Next one is the network layer is called as in X.25 is packet layer, that is packet link protocol. Okay. This is about the mapping in between X.25 and OSI model. At the same time, how the interface is going to be arranged in between DTE and DCE. So here this is the DTE and this is the DCE. So it is between physical layer to physical layer, from DTE to DCE, it is having the X.21 logical interface. And coming to link access, that is the data link layer, it is having the LAPB link level logical interface there in between these two link access layer. And coming to packet layer, it is having multiple connections. See here also it is having multiple communications. See, means multiple paths are there for sending that particular data. That is the virtual communication. So it is a packet layer. These dotted lights indicating what? This is the virtual communication. Virtual. So this is the interface in between the DTE and DCE. And next, what is physical layer? These three layers I am going to discussing now. First, what is physical layer here? Physical layer is mainly concentrated on physical layer in OSI. First, tell me what is OSI in OSI. What is the physical layer main aim? Physical layer is mainly for transferring the data in the form of bits only, right? So these bits are sending to the receiver in the form of signals, some electrical signals. For sending the data, electrical signals, we are going to use the physical layer. This physical layer interface mainly X.25 is also called as the X.21 also. It is called as X.21. Next one, it is mainly derived from RS-232 interface for serial transmission of the data. And it is also mainly providing the various communication lines that transmitting the some electrical signals. We are going to use the X.25 physical layer mainly for communication lines. And next one is this implemented mainly for the linking purpose. For linking between the sender and receiver, we are going to use the X.21 implementer. Next one is X.25. What is X.25 here? It is mainly responsible for connecting the DTE and DCE. This is the DTE. This is the DTE. For this is sender side. Here it is having one DCE. Suppose if it is a receiver side DTE, if it is receiver side DCE, it is also having one DCE. For connecting these two for sender side and receiver side, we are going to use the X.25. This is about the physical layer. And next layer is the data link layer. Data link layer in X.25. Data link layer is also called as the frame layer. At the same time, it is one of the most important essential part in the X.25 protocol. It is mainly for implementing or development of the ISO higher level data link layer. So, it is mainly talking about the HDLC, high level data link layer. At the same time, this high level data link is called as a LAPB. LAPB is nothing but Link Access Protocol Balanced. It is mainly providing the communication link and also transferring the data. Whenever the data is going to be transferred, that is going to be error-free among any two devices. That may be X.25 nodes. Means mainly it is providing the communication link. Whenever data is going to be transferring, there it is providing the communication link also. At the same time, it is transferring the data also. Whenever the data is going to be transferred, that is error-free. That is the main aim of data link layer. And this LAPB is nothing but Link Access Protocol Balanced. It is allows the DTE, that is Data Terminal Equipment, or DCE, Data Circuit Terminating Equipment, for starting and ending the communication. Suppose mainly LAPB talking for whenever the data is going to be there for starting or ending the session, starting and ending the session. At the same time, transmission starting. For starting the transmission, we are going to use the LAPB. LAPB main aim is starting and ending the session, at the same time starting the data transmission. And mainly this layer is providing the mechanism for checking the each hop during the transmission. We are checking the each hop. Hop is nothing but each device. We are going to check each and every device. Data link layer is mainly talking with the frames only, right? I already told hop to hop, host to host, and end to end. Hop to hop is nothing but device to device. This is in data link layer. Host to host is nothing but in network layer. End to end comes under the transport layer, means one end to another end. Means one address to one host network address to another address, that is comes under a network layer. Here I am talking about checking the each hop, each device during the transmission. Whenever the data is going to be transmitted, there we are going to checking the each and every hop only. It ensures the bit oriented because the frames having the zeros and ones only. Bit oriented, that may be error free, and also sequencing and ordering delivery of the frames. That is about the data link layer in X.25. And next topic is the X.25 network layer. This is the third layer in X.25. So packet layer is also called as the network layer protocol of X.25. This layer generally governs the end-to-end communication among the various DTE devices from DTE one end to DTE another end. For transferring the data, we are going to use the network layer. Based on what? Address. Based on the address, which address? Based on the address, we are going to deliver the X.25 packets among the each and every node and switches on the network with the help of PVCs. PVC is nothing but the permanent virtual circuits, or SVCs, switched virtual circuits. Based on these, using these particular PVCs and SVCs, we can transfer the data in X.25 network layer. These are about the three layers in X.25. And next one is what is the format of LAPB? LAPB, I already told, LAPB is nothing but link access. L is nothing but link, A is nothing but access, P is protocol, B is balanced. Protocol balanced. LAPB format. This is the LAPB format. It is having flag. Next one is address, control, data, and FCs. So first, what is flag here? Flag contain how many bits? It is having the 8 bits, mainly for starting and ending. So it is the starting, here is the ending. Starting and ending the frame. Each frame is having how many bits? Here is 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. It is having the 8 bits. And coming to the address. Address is also having the 8 bits only. It is mainly talking about the DT address, maintaining the higher layer only, mainly for identifying the commands and responses in between the DTE and DCE. We are going to use this address field. And next one is the whatever value is there, 0x01. It is indicating the command from the DTE and giving the responses from the DCE. At the same time, 0x03 is indicating the commands from DCE and responses from the DTE. That is about the address of X.25 LAPB format. And next one is the control. It is also having the 8 bits only. And next one, it is containing the sequence number, commands, responses for the control flow of the data. How the data is going to be controlled. That is comes under the control. And next one is the data. Data means based on the size. How much data we are going to be transferred based on that size. It is mainly talking about the upper layer data. And next one is the FCS. FCS is nothing but frame check sequence. It is nothing but frame check sequence. It is having the 16 bits of data. Mainly determines if any error has occurred in transmission. Whenever the data is going to be transferred, if any error is occurred, for that purpose we are going to use FCS, frame check sequence. These all about the LAPB frame format in X.25. And next one is the frame relay. Till now we discussed X.25. Now I am going to discussing about the frame relay. Frame relay is a high performance WAN protocol. Mainly frame relay where we are using means for transferring the wide area network to wide area network, we are going to use the frame relay. For transferring WAN to LAN or LAN to WAN, we are going to use the frame relay. It is a high performance WAN protocol. Mainly it operates in the physical and data link layer in OSI reference model. OSI is having 7 layers, right? Their lowest layers are the physical and data link layer only, right? Those 3 layers only we are going to use frame relay. It is a layer 2 protocol, mainly operates in physical and data link layer. It does not supporting the layer 3 processing, means it eliminating the layer 3 processing. And this frame relay mainly designed for the ISDN. It is main use on the ISDN is Integrated Services Digital Network. There we are going to use the frame relay, and mainly it is considered as a X.25. It is a connectionless service. Connectionless. X.25 is a connection oriented, frame relay is a connectionless service. It is going to be transfer the data more faster and it does not performing the error correction because it is connectionless. Connectionless, that's why it does not performing the error correction, only detecting the error. So whenever the data is going to be detected, it is going to be discarded. It does not correct the error. That is the frame relay because it is a connectionless service and it is used for faster data transfer because it is connectionless. So always the data is going to be transferred faster way in connectionless service, and more efficient network use we are going to use the frame relay. And why it is going to be replaced with the X.25? Because extensive flow and error control we are going to use frame relay. X.25 has its own network layer. For that purpose we are using frame relay. And next, fixed rate data at the all time we are going to use the frame relay. For these reasons we are going to replacing with frame relay in computer networks. And next we will discuss about what is DTE and DCE in frame relay. DTE, DCE in frame relay. DTE is nothing but terminals, personal computers, routers, bridges, all comes under the DTE, means user end user is nothing but DTE, customer location. Next one is the data circuit terminating equipment, that is DC is talking about the packet switches that are owned by the carrier for transferring the data through the WAN, that is DCA. See, here is DTE. I am transferring the data from this DCEs. This is the sender, this is the receiver, this is another receiver. For transferring this particular data using these DCEs, this is DCEs. This is a frame relay of WAN. So, means whatever connection is going to be there, that is going to be transferred from one DTE to another DTE in frame relay. And next one is the FRAD. FRAD is nothing but frame relay assembler or disassembler. That is frame relay assembler disassembler, mainly for handling the frames from other protocols it is used for providing the conversion to the frame relay networks. We are going to use the FRAD. This FRAD, that may be separate device or part of the router or switch, is nothing but FRAD. So this is the diagram for frame relay, assembler and disassembler. This is the assembler and disassembler. Both sides are there. Mainly it is talking about the two layers, physical layer and data link layer. Here there is no specific protocols are going to be defined in frame relay. At the same time, any protocol that are going to be recognized by ANSI, those are can be implemented in this. At the same time, LA links access protocol nodes, LAPF, can be used defined in frame relay layer 2 services. LAPF is defined in frame relay services, and it does not providing the any error control. I already told it does not provide error control because it is a connectionless service. This LAPF is a version of SDLC. At the same time, user address field of DLCI is as well as for the congestion control. We are going to use the FRAD in frame relay. And next one is the LAPF format. What is LAPF format? In previous slide we discussed it, right? This is LAPF is nothing but the link access protocol frame nodes. How the format is going to be there? This is the format. Here it is having the flags and address, information and FCs. Already we discussed in X.25 these address, information, FCs. I am discussing DLCI, CR, EA, DLCI and FECN, BACN, DA and EA. See first what is DLCI here. DLCI, it is having the length is 10 bits. At the same time, mainly for identifying the virtual circuit number, we are going to use the DLCI. And next CR is mainly it is having the only 1 bit address, and mainly for determining the commands and responses we are going to use the CR. And next one is the EA. It is also having only 1 bit. So it is mainly for the byte address, last byte address, that may be zeros and ones. And next one, extended address are there, that is FECN. It is talking about the explicit congestion notification, mainly talking about the congestion in the direction frame is going to be traveling. There FECN going to be used. Next one is the DECN. It is also having 1 bit only, mainly for it is forward, it is backward. Explicit congestion notification. So it is in opposite direction. Forward is nothing but it is the same direction, it is the opposite direction. Next one is the DE. It is talking about it is also 1 bit only, discard eligibility. For discarding purpose, we are allocating this one, that is DE 1 bit. So this is about the LAPF frame formatted frame relay. And next we will see what are the differences in between the X.25 and frame relay. First, in X.25, it has informal data rate. And coming to frame relay, it is having the fixed data rate. And next one is it performs the multiplexing and switching at data link layer, that is in X.25. Both are performing in X.25, that is in data link layer only. Coming to here, multiplexing and switching comes under the network layer. And next one, frame relay does not support hop-to-hop error and flow control, and it supports the hop-to-hop and error control in data link layer. Next one is it does not support the end-to-end and error control, but it supports the end-to-end flow and error control in network layer. So congestion control is required in frame relay, and coming to here, congestion control is not required in X.25. And next one is the call control signaling is required separate logical location, and X.25 is talking about the call control and signaling. That is about the differences between X.25 and frame relay. And let us see the summary of today's session. So first we discussed connection oriented network in X.25, and next one is the frame relay. We discussed what is connectionless service, that is the frame relay, and next we discussed what are the differences between X.25 and frame relay. Those topics we discussed in today's session. Thank you.